Hi guys, welcome to my YouTube channel. Today we are going to see regressions in machine learning. So, what are the topics? So, the topics are introduction to regression, types of regression, mathematics foundation of regression, data preparation for regression, training the model, interpretation of regression coefficients, and etc. So let's go to the introduction of regression. Exploring its definition and significance. Defining of regression. Regression analysis is a statistical model used for estimating the relationships among the variables, allowing us to predict outcomes based on the input features. Significant in machine learning. Regression serves as a foundational concept in machine learning, enabling practitioners to model relationship between dependent and independent variable effectively. Application widely used across various domains, including economics for forecasting, machine for risk assessment, and marketing for customer behavior analysis. Overview for techniques. Regression encompasses several techniques, each with its own unique mathematical principle and application, highlighting the versatility of the approach. Types of regression. So there are a lot of types and regressions which are used in our daily life. So let's see. Linear regression, logistic regression, polynomial regression, and regularization techniques. So what is linear regression? A fundamental modeling approach that expresses a linear relationship between independent and dependent variable through a straight line. So it will be a straight line. Logistic regression, used for a binary classification task, it estimates the probability of binary outcome based on one or more predictor variables. Polynomial regression, an exterior linear regression that models non-linear relationship by using polynomial regression to capture complex patterns. Regularization techniques, methods like lasso and ridge repression aim to prevent overfitting by a penalty to the model's complexity during training. Mathematical foundation of regressions. So let's understand the statistical models and the assumptions. So what are the statistic models? Statistic models. Regression relies on statistic models that describes the relationship between independent and dependent variable using mathematical equations. Key assumptions. Common assumptions include linearity, independence of errors, homoscedasticity, and normality of error terms, which ensure the model accuracy. Error minimization. Regression techniques for minimizing the distance between the predicted and actual values, primarily through the last square methods. So, in this error minimization methods, there will be a primary through these square methods, and the regression techniques focus on minimizing the differences. Cost function. The cost function quantifies the model's performance by calculating the prediction error scaling. So, this will optimize our cost. Data preparation for regression. So the data preparation is used to ensure the quality input data for reliable models. So what are the data preparation regressions? They are data cleaning, feature selection, scaling, and encoding categories. Data cleaning, the process of addressing the missing values, removing the outliers, and correcting errors to ensure the integrity of the dataset prior to the analysis. Identify the most relevant variables of the target outcome is the feature selection, whereas the scaling is normalizing or standardizing data to ensure that all features contribute equally to the regression analysis. So these are all the data regressions. Okay. So now we will go to the training the model. So how can we train the model? There are various methods to train a model. So they are training dataset, algorithm dataset, iteration process. Wait a minute. Convergence. Training dataset. A subset of dataset assigned for training the model, where the model learns the underlying pattern and the relationships. So, algorithm selection. Choosing the appropriate regression algorithm based on data characteristics, computational consideration, and the desired outcomes. Iteration process. The training phase often involves in multiple iterations, which the model undergoing updates to improve its prediction based on the error feedback received. Interpretation of the regression coefficients. So these are the interpretations based on which the regression coefficients can be found. So the meaning of the coefficients. Each coefficient represents the change in the independent variable for one unit change in the respective independent variable controlling the others. Significant testings. Statistical tests, for example, t-tests and examples, determine whether their coefficients are statistically significant, indicating their influence on the dependent variable. Confidence intervals. These intervals provide a range of plausible values for the coefficient, helping to assess the uncertainty associated with the estimates. And multi-collinearity. There is high correlation between the independent variable and the dependent variables, and interpretation will be necessity. Model evaluation metrics. So now we will see about how we can assess the model performance. So there are basically many methods, but we will see the most commonly used methods here. R squared, adjust R squared, RMSE, and MAE. So what is R squared? The metric indicates the proportion of variance in the dependent variable that can be explained by the independent variable, reflecting the model accuracy. Adjusted R square, a modified regression accounting for the number of predictors in the model, a useful metric for comparing the models with the different numbers of predictors. RMSC, root mean square method. So you guys will have seen this root mean square method in most of your subjects and chapters. So it is a most common method. Measures the average errors of the model prediction and the providing insight into the model accuracy of the training data set. MAE, mean absolute error, calculates the average absolute difference between the predicted and the actual values, simplifying the error analysis for regression models. Overfitting and underfitting. So, uh, understanding model performance trade-offs. So, the overfitting and underfitting are four types basically. They are the definitions of the overfitting and visualization and the regularization techniques and the bias and variance. Definition: overfitting occurs when a model is too complex and captures noise, while the underfitting happens when the model is too simplistic. So basically, overfit happens when when we if I take an example like a software, if it is more complex, then the overfitting may occur, and if it is too simple or the it is does not acquire the required requirements, then it will be a underfitting. Visualization, graphical representation illustration the distinction between the overfitted and the underfitted models, highlighting the error patterns and the training test datasets. Regularization techniques. Techniques like lasso and ridge regression help to reduce overfitting by constraining the coefficient of the model. Bias variance, the balance between the model and the optimal model minimal and the variable. Techniques to improve the regression model, enhancing model performance. So, feature engineering, hyperparameter tuning, assemble model, and cross. Feature engineering. So, feature engineering, the process of creating new features or modifying the existing ones to better capture relationship in the data and enhance the effective provider. Hypermeter tuning, fine tuning performance, to optimize the performance, often through techniques like grid search or random search. The other methods are normally available. Application of regression industries. So there are a wide range of applications of regressions in our industries. So let's see the various sectors like finance, healthcare, marketing, and real estate predictions. For example, let's take finance. So there are stock markets where you can trade. So there the regressions will be used, and healthcare, which are used for predicting the patient's outcomes based on historical base trends and the treatment efficiency. Marketing, regression assists in understanding consumer behavior by analyzing the purchasing trends. Real estate predictions, real estate valuation models utilize regression to forecast the property prices based on the locations, size, and the market conditions. Challenges in regression analysis. So what are the challenges? Data quality issues, model assumptions, interpretability, and computation. Inaccurate, incomplete, or noisy data can significantly impair the regression model performance, necessitating the careful data handling. Modern assumptions. The regression rely on specific assumption about relationship. Violation of this assumption can lead to misleading results. So now we can wrap up this regressions, I guess. So what is the conclusion we got from this chapter? Summarizing the insights and looking ahead. Key takeaways. A summary of the essential concepts of regression discussed, reinforcing its importance in predictive analytics and model evaluation. Advantages. So, what are the advantages? The ongoing evolution of the regression methodologies continue to enhance their abilities. Also, the AI for income outcomes. Impact of AI in regression. So, what is the impact of AI in regression? Machine learning AI impair regression model, allowing for advanced predictions, adaptability through the learning from the increased data volumes. Trends in machine learning. The emerging trends include a shift towards automated machine learning practice, a critical component of our data. So, thank you guys, and wait for the next video till I upload. And I'm signing off.